So in this video I'm going to teach you how to implement the bubble sort algorithm in Python. And basically I like to show how it works under the hood through some uh, visuals and my way of explanation. And then this understanding you can easily implement in code because it's like a high level of understanding but deeper. And then it's easier for you to materialize it in code, contrary to the traditional teaching where you have to memorize the code without understanding how it works, like those college ways. Which I'm not saying I'm against college, but there's so much misleading in there. So basically, bubble sort just sorts the array in ascending order or descending order. So from the smallest to the biggest, or from the biggest to the smallest. So basically, what it does it that it, for example, in the case of find of in ascending order, it just takes the biggest element and it moves it to the most right, and then the next biggest element, and then the next one until the whole array is sorted. So I like to teach it like this. Let's say we have this array which has 5 elements, but it can have like n elements. It doesn't matter. Uh, so the first thing is that I like to take the bigger array. What did I do here? So now I have to brush it. Okay, I'm going really down here. I need to move up. So one, two, three, 4, 5. Okay, this is the biggest array. Okay, then the next thing is that I like to take another array with 4 elements. One, two, three, 4. Then the next thing is I like to take one with 3 and one with 2. So what I did is that I split this array into mini arrays. And in the first iteration, I'm going to take the biggest element of all and then move it in here. Then in the second iteration, I'm going to take the next biggest element and move it to the most right. Then in the other iteration, I'm going to take the other biggest element. Okay, so two in here, and then the next biggest element is 0. Okay, so basically I have like one, two, three, 4 mini arrays. So uh, there are going to be like length of the array minus one iteration. So in the outer for loop, we are going to iterate as many times as mini arrays that we have, which is length of the array minus one, because this the two elements can form the last mini array. There are no more mini arrays because we cannot have mini arrays with just one element because it's just already sorted. We don't have to find like the minimum or maximum element in there. So basically, for the outer loop, which is the number of iterations that we need to find uh, the biggest element or the smallest element. I'm taking the ascending order, so the biggest element moving to the right. So for this one to the right, then for what's left, then to the right, to the right, to the right. So let's say in here we find the biggest element for the whole array, then once this is gone in here, what's left? It's left this part unsorted. Okay, find the biggest element for this one. Then once we moved it in here to the most right, then we need for this one with 3 elements, then with 2 elements. So we need like as many iterations as mini arrays that we have. So like one thing should be clear in here, that we need an outer for loop with length array minus 1, the range of the for loop. That's how many cycles we are going to have in the outer loop. Then for each mini array, we're going to use another for loop to move the element from the left to the right, like 1, 2, 3. For example, let's say we have this element in here, then we have another in here, then we have another in here. Then we are going to say, for example, let's say this is a mini array. If array j is greater than array j plus 1. So what we do in here is that we take an element, and the index should start always from 0 because it's from left to right. And we compare it with the next one. If this is true, if this is leads to true, which in this case is not because 5 is less, we swap. So in here is false, so we don't do any swapping. Then we go array 1 because j is increasing, because j is going to get the indexes from 0 and then to a limit, which I'm not going to find out at now. I mean, like a few seconds later. So, and when j goes in here, array 1, then it's going to compare it with array j plus 1, which is array 2. And this true is 8 greater than this? Yes, so we swap. Minus 1 goes here, and 8 goes here. We just change positions. And then array 2 is greater than array 3. Is 8, because then this becomes 8. Is 8 greater than 0? Yes, so we swap again. So 8 goes here, and 0 goes here. So 8 moved to the top, excuse me, to the most right. And then we do the same thing for mini arrays, because in here we set a flag now, like f1, for example, which from this border and to the right is sorted. Then we have to sort what's left, and what's left is these other mini arrays. Okay, and j is going to range from 0. Then we don't want j to go out of the mini array, so j, it should go from 0 then to the length of the array through which is being sorted, or mini array, but in this case should be length of array minus 1 minus e. Okay, this one you have to remember. I know how it works, but I don't really I don't really I know why j should go like to this kind of range, but I cannot explain it right now why minus I, or maybe I can. For example, when I equals to 0 in the first iteration of the outer for loop, uh, j goes from 0. For example, let's say we have a list with 4 elements. Length of a is 4 minus 1 minus 0, so it goes from 0 to 3, and then 0, 1, 2. this is the number of elements that we need, and we don't get an index out, like an index error. Then when I equals to 1, j should go from like 0 to 4 minus 1 minus 1, from 0 to 2. Okay, so within increment of I, j the range of j goes down. So let's see it in code. Now I'm going to launch my Jupyter notebook. So basically, we need two two for loops: an outer for loop for the mini arrays, and for each mini array we need an inner loop. Okay, so I'm going to call it bubble sort, and it's going to take an array, and it's going to return this array, but it's going to return it sorted. So, and then we need for loop in here, 1 2 3 4 spaces, and the for loop in here. So an outer for loop, which means as many cycles as mini array, because we are going to sort, like we are going to find the biggest element for every array, and we are going to move it to the end of the array. So for I in range 0 to length minus 1, and length should be the length of the array. And now with the range in Python, this goes from 0, and the last value is not included. So let's say we have like 5 elements in the array, so from 0 to 5, minus 1 is from 0 to 4, and also 4 is not included. There are 4 cycles because it's 0 1 2 3. So if you do, for example, for I in range 0 or 4, it's going to print 4 elements: 0 1 2 3. And when the array has 5 elements, we have 4 mini arrays. So as long as this number as long as these cycles are equal to the number of mini arrays, it's okay. And the next thing that we're going to do is j, for j in range. So we sort the first mini array, then this one goes to 0, and this one continues doing work until it finds the maximum element of the first mini array and moves it to the right. And then I goes to 1, and then is the next mini array, and this does the whole job. And then I goes to 2, and that is the next mini array. Okay, as I explained in the visuals. For j in range 0 to length minus I minus 1. In this maybe you need to do some examples yourself to understand why it's like this with the visuals. But as I explained, when the I is incremented, the mini array has less elements, and we have to do this. Okay, and what how do we find the maximum element in a mini array? We start comparing the elements. If array j is greater than array j plus 1, if this is true, it means that we have to move this array j, which is the element bigger than next one. We have to swap positions now. So this one goes to the place of this one, and this one goes to the place of this one, just swapping. So one goes to the right, the other goes to the left. The bigger one goes to the right, the smaller one goes to the left. We say array j equals, equals to array j plus 1. So the element with this index is going to have the value of this one. Then we say array j plus 1 is equal to array j. But we have one problem in here, because when we say this, it's overridden in here, and the value of this is not the same anymore. So we need a temporary variable to store the value of array j before overwriting it, and we say array j plus 1 equals to temp. And once all cycles are finished, this should be sorted. So as I explained, in the first cycle, uh, the first biggest element is moved to the right, and then uh, in another array, mini array, the next biggest element is moved to the right, and so on until all mini arrays are sorted. So if I do an example now, like bubble sort, okay. So -1, 5, 199, 22, it works. So if you want, maybe in descending order, you just have to change this to this, but for now it's okay. So uh, maybe try another example. -1, 0, 34. Okay, it works. I mean, maybe it has its own faults, I don't know, but for now it works. So if you have any like methods on how to write it differently, or I don't know, just leave a comment. And lately I'm doing some studies on these algorithms, and I'm implementing them in Python. So feel free to comment below and make sure to subscribe for more content. So thank you for watching, and goodbye.